Hey, YouTube. Hey, Samuel.
Hi there, how are you doing?
Doing very well. I'm super excited to be talking about Pydantic and your plan and all these changes. And I know there's a bunch of people I've seen on Twitter and here on YouTube that are going to be excited. So thanks for being here. For those of you listening, be sure to throw some comments and thoughts into the live chat, and we'll try to get those into the show. Ready to kick this off?
Absolutely.
All right. Samuel, welcome back to Talk Python to me.
It's great to be back. When was it? It was in the middle of, it was in COVID, wasn't it? I seem to remember.
It
Sometime
was
last year.
core COVID. Yes, it was just, what was that, about 15 months ago? Yeah,
Yeah, I
April
think it was sometime last
2021.
year. Yeah, I was in my attic I'm now in the office. It's a representative.
Locked exactly, locked down in the house and all those kinds of things. Yeah, for sure. So yeah, it's great to have you back. We talked about Pydantic back then. Obviously, we're talking about Pydantic now as well. I would say it's grown tremendously since then. It was already quite popular then.
Yeah, I think I don't have right now off the top of my head good metrics on insofar as you can quantify the growth of these things. I think it's grown a lot, but I think the feeling for me is it's become a lot more companies and a lot more people have started to rely on it, and it's become a kind of core tool that they expect to work in the way you expect PyTest or Django to work. Not quite perhaps at those levels, but in moving in that direction. And yeah, I guess I'm probably jumping the gun, but at the beginning of this year, I was thinking about it, and I was obviously super proud of how many people were using Pydantic and how useful it was being, but I wasn't quite so proud of its internals, which is why I started thinking about what it would look like to kind of start again, because obviously V2 was an opportunity to break stuff. Not that we haven't broken things in minor releases when we shouldn't have done, but like to formally break things and do it right, where it was obviously, I guess, wrong from the beginning.
Sure. Well, the goal, I'm sure, is not to go out and break things, but sometimes in order to take years of learning and experience and usage and turn that into the way you think it should be, some things may have to break, right?
Yeah, I think that when I first released Pydantic, it wasn't. I've subsequently built projects I thought were going to be really popular, and there's been, they've varied in their success. But I literally built Pydantic for me and put it on, put it on PyPy and then put it on Hacker News to see what would happen. But because of that, I thought about there were some esoteric design decisions that were the stuff I wanted, but
Mm-hmm.
on reflection, they're not right for a popular library used by lots of people. Strictness being, I guess, the most obvious example, but a bunch of other stuff.
Yeah, we'll talk
Um,
about strictness. We'll talk about a lot of these changes. But why do you think it was popular?
I think it came along at the right time.
Yeah, I
I think
agree.
it came along when type hints were just getting popular in Python. They had been around in some guys for like ever, right? You could do something with them in 2.7, but they were just beginning to become a thing. MyPy was coming out, but I suppose I was not the only person who was frustrated by the idea that they didn't have teeth, that they were there, but it seemed kind of weird, right? If you came from a Rust or a C++ or a C background, types are everything, and the idea that they were there but they meant nothing was a bit of an anathema to me. And it started off with a can I make them work a bit, and that was 5 years ago, and here we are.
Yeah, I agree that coming along at the right time was probably part of the magic. I think there was just some libraries and some frameworks who decided these types should have meaning. Like you
Yeah.
said, there was a couple of web frameworks, obviously most notably Fast API, but there were other ones as well who were taking the ideas of here's some type definitions in Python, and what could we do with that? Like, could we actually make that mean something to help the developer experience?
I think that's true, and I guess I got some stuff right in doing documentation quite well quite early on. I know that like it wasn't perfect, but it did the job at the time. Fast API and Sebastian's amazing in lots of things, but his capacity to write documentation that is almost a story that almost leads is enjoyable to read in the way that documentation normally isn't. Uh, Obviously, yeah, being adopted by Fast API like strapped rockets to Pydantic, but I think the other thing that made an enormous difference is that I came to Pydantic as a developer, not a typing academic, and I know there's a lot of debate about whether or not the typing world of Python moves a bit too far into the world of like the theoretical. But I always wanted it. For me, it was always obvious that a string of 1, 2, 3 should be coerced to an int. And there's a lot of people who will say that's not useful, and then there's a million different ways in which they use it, and they don't even realize, because
Yeah.
you think it's really obvious when you have ID equals 1, 2, 3 in a URL that 1, 2, 3 is an integer, but obviously when you're passing a URL, there's no way to say that is actually definitely an int. So some of the lax stuff, the coercion, I think has been the thing that sets Pydantic apart from some of the other libraries that were perhaps more formally correct, but I would argue
Right.
less useful in lots of contexts.
Well, I also think the more that you work on the web, where what you're accepting is out of your control,
Yeah.
You want more help, and you want more validation, and you want more guardrails. People are posting JSON documents of who knows what to you. There's the query strings and the URL parameters that are always strings, no matter what they're supposed to be, and stuff. So yeah, I think Pydantic especially fit well in the API side of things.
I also think there's the risk of getting a bit kind of like fuzzy and COD philosophy about this. There's a value in remembering what it was like to not be that good a developer and making it easy to use for beginners. And there's definitely a world of developers who want to, whose primary interest, it feels, is proving how much they know rather than making it easy for people. And Sebastian is even better at this than I am, but I think Pydantic does a good job of it, of being easy to use. And if you're new to developing, you and I know the difference between bytes and string, and obviously we would, laugh through our nose at anyone who got them confused. But the fact is that when you're new, they look like two identical things, and one's got a B at the beginning and the other one's got an F at the beginning. And what does any of that mean, right? Like,
and so just ignore that part. Yeah.
Right. And so the fact that you can pass bytes to a string field saves people a lot of head scratching.
Mm-hmm. Yeah, it certainly has taken on a life, quite a life in the Python space, and many different frameworks and libraries are dependent upon it, which is great. Some stats that you put in this article we're going to talk, or this plan that we're going to talk about, there's 72,000 public repos that I'm guessing are expressing some kind of dependency on Pydantic, and then 10,000 GitHub stars. Yeah, that's coming up on 11. That's pretty amazing.
And the download count, I think it was 24,000 a month. Sorry, 24 million a month when I last looked from PyPy, and that doesn't include distributions. Pydantic is distributed with, I think, every major Linux distribution. So downloads in those contexts won't be included in that. So yeah, it's widely adopted, and it seems to be getting more widely adopted as time goes on.
Yeah, for sure. Just to back up what you're saying, to an Army captain out there, says Pydantic is very easy to onboard. Yeah, it's just because it does what you would expect it to, what you would want it to do.
Yeah.
So let's see. One thing I wanted to sort of touch on a little bit before we got into the plan officially is, let's just highlight some of the frameworks that are making core use of Pydantic. Obviously, we talked about Fast API, right?
Yeah.
For people who don't know, maybe tell them real quick, what is Fast API?
Fast API is an amazing web framework that allows you to, I think if you scroll down, I think that probably pictures will be better than words.
Yeah.
You use Pydantic and types generally to define what data people can pass to your endpoints, primarily, as per the name, for developing APIs. And yeah, it makes it super simple. I think there's an example down somewhere a bit further down on the homepage. Maybe there isn't. Maybe it's on getting started. But there we are. Yeah, you see here whether it be URL parameters like item ID or query parameters, or obviously the body. They're all validated with Pydantic, which cuts out enormous amount of the work of building APIs.
Absolutely. And then there's a couple of things interesting. You have Pydantic models, which are Python classes with type, a field : type. So you express the type information about it. And then you can say, this API function just takes one of these and it'll automatically pull that data in and validate it using Pydantic through like the body. But then also you can express that is the response model or the input model, and it'll use Open API to actually generate the documentation. So there's all these different ways in which
So right,
Fast
so
API is made better. Yeah.
so the powerful thing about Fast API is that by defining a relatively small amount here, we just define it as like a 3-line function to define our endpoint. We get JSON schema for the input. We get so then we get docs built off that, and we get obviously docs on the return type if we annotated it with with what's returned. So yeah, from and obviously the value, and I can see from your tabs where you're going to go next. Like you define something in one place, and you can then use it for your input and for your return type, and then in your database.
Yeah,
And,
absolutely.
and
So yeah, this is the most well-known example for using it on the API layer, the web layer, but there's also some cool examples of databases as you pointed out there, right?
yeah, so
Did this surprise you when you saw these? I mean, you probably had the API stuff in mind, but did the database surprise you?
it did a bit. I mean, I like haven't looked at Beanie in lots of detail, but like yeah, it's like yeah, it's amazing that these things are coming along and being built and leveraging leveraging what Pydantic can do. I'm not a big ORM fan myself. I'm a bit old-fashioned. I like to write my SQL. Not sorry, I like to write SQL.
Mhm.
Not MySQL. So I haven't actually used them, I have to say. But Fast API I've used a lot, and I've found absolutely amazing. But I can't talk about Beanie or SQL model beyond uh, beyond having had a quick look.
Yeah, you're like, oh, interesting. What are they doing with this thing I created? Yeah, so I just want to give a quick sort of awareness shout out to Beanie, which is an async ODM, object document mapper from MongoDB, like an ORM, but there's no R, so D for document, based on Motor. So it's pretty cool. It takes the asynchronous driver from MongoDB, and then Pydantic, you just express your models, your documents as Pydantic models, which map really well because you can have hierarchies of Pydantic classes and models, which maps perfectly to document databases. So yeah, this is actually what TalkPython, the Python Bytes websites are built on, which has been really nice. And then obviously Sebastian Ramirez created SQL model, which is the same idea, but for SQL, right? It's built on top of SQL Alchemy, but you actually define your classes as Pydantic models, and then that finds a way to sort of work with SQL Alchemy to still do the same stuff that it traditionally has done. So
Yeah, I think there was
pretty neat.
one of the complaints people had was that they were having to define their data twice. They would have a Pydantic model, and then they would have a SQL Alchemy model. And so yeah, it's not very surprising in a way that we found a way to combine them into one. Again, I'm not an expert on the internals of SQL model, but yeah, the two things look similar enough that like at a first pass, you would think it would make kind of sense to squish them together.
Yeah. And one interesting thought about this is, if you're going to work in SQL model, or you're going to work in Beanie or something like that, and you decide, no, I actually want to switch to a relational database, or I want to switch from a relational database over to MongoDB or something like that. If it's all expressed as Pydantic models, like how close are you? You know what I mean? Like it's very little work to sort of make that transition. So it's cool
And
that Pydantic is this kind of like
and there's actually a
abstraction
cool
layer.
project. There's a cool project that I was discussing with Adrian, I think it's Garcia, yesterday, which is using Pydantic models to define data coming in from already Google PubSub and from AWS SQS and potentially from
Okay.
Redis. So again, it's the same idea that like once you define your models in Python, it wouldn't be that hard to switch from AWS to Google, or even to like a database type tool like Redis.
Yeah. Wow. Amazing. Teddy out in the audience says, we use data model code generator to generate our Pydantic models from JSON schemas. Are you familiar with that?
Yeah. Yeah. So obviously, just as you can generate a JSON schema from a Pydantic model, there's a third-party tool that lets you go the other way and generate Pydantic models. It obviously won't do everything for you, validators and stuff, but it gives you the first start.
Nice. Let me throw one more out there before we dive into the plan, which is where we're going. How about JSON to Pydantic converter? Have you seen this website?
I I did not know that existed until now.
All
But I
right,
guess it's
yeah.
using that same tool under the hood, is it? Or
We'll
maybe
watch
it's
this.
not because it's got.
It may be. I'm not actually sure. I haven't seen it mention it, but it doesn't really say. So,
I'd say not because it doesn't look. That's not JSON schema, right? That's just
oh,
like.
what you do is you give it an example. Um,
Oh, that's very cool.
you give it an example JSON document. I'm till 27. So you give it a JSON document, and it will actually. When I first heard about this, well, Pydantic will already generate JSON. Like, no, the other way. You give it a JSON
That's
result,
amazing.
and it will generate the data model by looking at it. And it actually, even if you have like hierarchical stuff, it'll create multiple base model derived classes and all sorts. This thing is this is pretty sweet right here. This thing.
That's pretty powerful. Kudos to whoever built it. Yeah, I hadn't heard of it, but
Yeah, and I've thrown massively complicated JSON documents at it, and it's just like, well, it's going to take 8 classes, but here you go, and it just writes them all. It's
yeah.
fantastic. All right, well, with that, let's talk about the plan. First of all, before we get into the plan, I just want to say, well done on this. You know, we covered this on the Python Bytes podcast 3 or 4 weeks ago, something like that, and the response was, oh my gosh, this is incredibly detailed, incredibly well thought out. I think somebody in the audience commented like, there are companies that have been created and founded with less thought about the future into it than that. So yeah, nicely done.
Thank you. Yeah, I
Right.
spent a lot of time, quite a lot of PyCon talking about this to people and saying, talking about little bits of it. There was a lot of it in my brain. And Sebastian, who is kind enough to sponsor me, but also obviously is maintaining Fast API, was kind of asking me what it was going to do. And I kept being like, oh, it'll do that thing and it'll do this thing. And then I got to the point of realizing, and probably about 70% of issues on Pydantic's issue tracker, I reply with, don't worry, it'll work in V2. And I realized I got to the point where I really owed the community an answer to some of these questions. In fact, the first bit of feedback I got from it was I'm dyslexic and I'm quite slow at reading, and those red time notes never make any sense to me. So I just put 10 minutes in at the very beginning and then forgot about it as I extended it. And the first feedback was, great article, but how the hell is anyone reading that in 10 minutes? And so I pulled a new number out of thin air. But
so yeah, it's 25 minutes reading time, which I think is actually fairly accurate, depending on how thoughtful you think about these various things. So the plan is,
I've got to have a shout out to one joke on Twitter. Someone was like, when it said 10 minutes, they were like, 10 minutes to parse, 2 days to validate, which I thought.
Oh yes, well done. Very, very Pydantic like. Okay. So why do we need this plan? Why
like
V2
I said,
to start?
So I think, like stepping back a bit, most projects, once they're mature and in widespread use, like people don't sit down and tear them to pieces, right? They mostly stick with the same kind of warts and people polish the edges, but like that there's not a like from scratch rebuild. And often when there is from scratch rebuilds, it offends a lot of people because they don't know what's happening, and they're like the cost of migrating is quite high and they're turned off it. So, but I thought that there was enough wrong with the internals of Pydantic, and there was enough opportunity to do stuff way better, and there was enough reason to do that because there were enough people using it that it was worth me sitting down and spending 6 months, but we've passed 6 months building it right. And like I say, this is there was one of the like, not stats, but one of my observations was looking at. So there was a Stack Overflow survey of what technology people are using, and Fast API had, I don't know what percentage, but like 6% market share, right? And then below it, they were talking about clouds and which clouds have what market share. Now, if you assume the same number of people are using web frameworks as are using clouds, which is an approximation, but not a mad approximation, then you would say that Fast API and therefore Pydantic have a bigger market share than Oracle and IBM combined in slightly different markets, and obviously without the revenue to go with it. But like, it makes you realize that like getting this right has a massive effect on lots of people and on and secondly, that I don't have a clue how many times Pydantic validates data a day. between Netflix and Facebook and Amazon and Microsoft and everyone else, but it's a high number, right? And so the environmental impact of making Pydantic 10 times faster and therefore consume 10 times less CO2 to do a validation is, I suspect, not trivial. It's virtually impossible to get an accurate number, but something real.
That's a really interesting way to think of it with, almost having a responsibility to lessen the compute load. And when, you run in your own website and it does a couple of users an hour or whatever, like who cares, right? But when
Yeah.
you're talking a million requests a second or whatever it is across all the different
Yeah.
people using all the different frameworks across, right? That actually
It
is
adds up, I
meaningful.
suspect. And
Yes,
like
like
you
does well.
think about a web server, assuming your database is doing all of the heavy lifting that it should be doing. What's the next biggest thing? Well, there's uh, TLS termination. That's expensive, but like again,
Mhm.
that's done by some optimized C and Nginx, or probably outside your code completely if you're using a platform provider. What's the next biggest thing that your code is doing CPU wise? Well, it's data validation basically.
Yeah, conversion,
Yeah,
serialization, deserialization, validation, and all that lives in the Pydantic realm. Yeah.
yeah,
Also, I talked about two frameworks, and I know there are others, like Pydastic for Elasticsearch, um, where the validation and the data exchange is the database exchange as well, right?
yeah,
That could be
yeah,
very important for if you make this much faster. I don't know the numbers for Beanie precisely, but I know that a lot of those ORM ODMs, if you go and query and get like 10,000 rows back, the vast majority of that time is how do I construct and fill out 10,000 objects in memory,
yeah,
right? And if you make Pydantic faster and Pydantic is that object, well, there's a
yeah.
huge
It's
bonus
it's
right
more
there.
than just. And I think the other thing to say is we've talked about web applications, and from Fast API being the kind of most high profile user of Pydantic. We talk about that a lot, but a lot of its usage, if you look at stuff that Explosion AI are doing,
Hmm.
it's in data science and AI, and it's exactly that. It's like data sanitization into and out of models or into and out of databases, and there you are talking about like really massive amounts of data.
Absolutely. All right, let's get into it. So we talked about the plan. How about the roadmap, the timeline, things like that?
So we're behind a bit, but we're not too far behind. I released version 0.1 of Pydantic Core yesterday, so that I'll come to what that means in a minute. But that's the first step of the plan. Um, I'm about. I think I've either closed or merged 25 PRs today, trying to get through Pydantic and get version v1.10 out. So I'm halfway. I'm not halfway through. I'm some bit of the way through two, to be precise.
Right. And
Yeah,
so what you were talking about in the plan, as you said, there's a bunch of open PRs, a bunch of open issues. Let's merge in as much of that as possible to sort of capture it and
yeah.
then move forward in this rewrite that we'll talk about.
Right. Yeah, exactly. So get 1.10 out, which is the same basic code base with a bunch more stuff added that I've because I had a job and was really busy earlier in the year. I kind of dropped the ball on reviewing those PRs, and they kind of got out of control. But get them dealt with, and then get to a kind of clean slate, and then make the big move from V1.10 to V2.
Yeah. Okay. And you do talk about there being breaking changes. We'll get into some specific details there, but probably the most relevant to this entire rewrite is this thing you're calling the Pydantic-Core. Yeah.
Yeah. So this started off as a kind of small experiment with me saying what would a kind of thought experiment. What would Pydantic look like if it was implemented in Rust? What would its internals look like if they were implemented in Rust? And that experiment effectively worked. And sure enough,
Mhm.
Pydantic Core is written in Rust and does all of the core data validation, and it will do a lot of the serialization. I haven't built that yet, but that I intend to build into Rust. So there's an awful lot that will stay in Python, but Pydantic Core is written in Rust and uses the amazing Pyo3 library to bindings to write Rust code that's callable from Python.
Yeah.
Uh,
Maybe tell
yeah,
people about Pyo3 real quick, because this is how you write it and write the code in Rust, but then expose it to the rest of the Python
yes.
aspects of
So I
Pydantic,
guess,
right?
yeah, Pyo3. I'm not a good C developer, and I'm going to use the wrong terminology and be shouted at. But like, it takes the Python ABI for C, so how you would write C code to be used from
Right.
Python, and effectively makes that available in Rust. Rust has great interop with C, and so yeah, it basically takes all those types and exposes them all in a type safe way that you can then consume. So if we stop here and we look at like summer's a string, right? Where
Mm-hmm.
Pyo3 is taking care of all the hard work of you passing two ints from Python into this function, converting them to usize. Then the logic inside is pure Rust. It's adding two usizes and converting the result to a string. And then again, Pyo3 is taking care of returning it, and in particular using this PyResult result type in Rust. Without going too far down the rabbit hole of how Rust works, Rust has an amazing model for how to deal with errors that basically stops you from ever ignoring an exception or what they call an error. And that's these results, which are basically, they would call it an enum, but from Python world, think of it like a union, which is either okay, it went well, or error, it was an error. And so you
Right.
have to
Okay.
return an okay, or you have to return an error. And when you consume that in Rust, you have to deal with the error case. It won't let you ignore it. But that maps really nicely into Python exceptions. So here we're returning okay, so we'll get a result. But if we used py error and return that, then you would get an exception when you called the function.
Mm-hmm.
The
Interesting.
So the powerful thing about Rust, beyond obviously it's faster. Everyone knows that, and it does mean that Pydantic Core is much faster than Pydantic, and Pydantic 2 will be much faster than Pydantic 1. I think it's probably quite rare to see a library in a version update get significantly faster, let alone like 10 to 50 times faster as Pydantic 2 will be. So that's been achieved, but there are other advantages that you get which are perhaps less obvious.
Mm-hmm.
One of them is like recursion without a performance penalty. That means that Pydantic core data validation is truly recursive all the way down and allows you to build effectively any crazy combination of different validators into each other. Because validators are this basically pile of think of them as classes in Python. They're not classes in Rust, but that call each other recursively all the way down. And you can, one of the other advantages is like tiny functions, which allow you to split code up and make it easier to edit one thing without breaking other things.
Right. Because in
Again, is like,
Python, it's not entirely obvious to people coming from languages like C, C Sharp, Rust, and so on, that just calling a function itself is pretty expensive, relatively speaking, in Python.
yeah,
Yeah.
I'm on the edge. I'm on the like wing of people who would say if you're worrying about the overhead of calling a function, you're probably not writing the right language most of the time, right? Like
Yeah.
it's a big number, but it's a tiny number in most contexts. But I think there's definitely a world in which like end users, people building web apps in Python, definitely it's for companies should and will be using Python. But the libraries that underpin that they use, there's big value. Value is a complex term in open source in itself, but let's use the word value and ignore that what it might mean in implementing those libraries. The second step down, so the Pydantic, the HTTP framework. In Rust or in I think in Rust basically, because those are there are three libraries that have real bindings for Python. C, I don't want to be writing lots of C, and I don't think many people do. Well, I'll say that. Rust obviously, and then there's C++ and Boost. And I think the developers of Pyo3 came from using Boost, and they basically built Pyo3 to be better. And I've used Boost a bit, but I found Pyo3 to be really impressive.
Yeah. I think your comment about should you be worrying about those loops is super relevant. There's certain libraries where Pydantic is certainly among them. It's used so much that these little tiny portions, probably just a very small slice of the code that is applicable, is actually a pretty significant hit in terms of overall performance. You think like SQL Alchemy and like the serialization, deserialization bit, right? That's a small part of the library, but that's something that just is ever, omnipresent, right? And this internal validation and stuff that you're thinking about doing in Pyo3 or in Rust, combine it with Pyo3, it makes a big difference, even if it's only a relatively small portion of the part that people perceive it to be,
Exactly. And coming back to my environmental point, the environment doesn't care if you take a flight, or I take a flight, or I miss a flight. But like, obviously, the environment does care if we can reduce the number of flights taken worldwide by 10%. And because of Pydantic's widespread use, that's why I'm saying getting Pydantic to be 10% faster, you probably won't notice, but overall, we will hopefully make computation in the cloud a tiny bit faster.
Absolutely. Question from the audience. Magnus says, will a user be able to write data validators in Rust for Pydantic 2?
That is a difficult and complex question. There is an open issue on Pydantic Core's issue tracker about it, and I have proposed a way that it might be possible. The story of shared libraries, DLLs, in Rust is not quite as pretty as it could be, and I really don't want to build basically another way of sharing dependencies beyond PyPy, where you're like, okay, you need to install Pydantic from PyPy, and then you need to install this other package perhaps from PyPy, and then you need to use this other code to link the DLL so that we can do dynamically link those libraries. That sounds like an enormous maintenance overhead for me and for people doing it, because people find it hard enough to share code and use code from PyPy. So PyPI. So
then how do you deploy that, and how do you get it compiled?
Right. So very briefly, my theory for an answer is, actually, I'm not gonna go down that rabbit hole right now. But there's an issue that I think explains it, and I'm happy to talk about it there. And
sure. If you don't add it now, you don't have to live with the consequences of choosing that.
That's the other thing, right? That like someone comes along and has a really bright idea, and in 10 years' time, I'm still answering questions about how to make it work.
Yeah, exactly. Okay. You already mentioned the performance, but just working our way through the plan here, the next step is to say, hey, the benchmarks indicate this is 4 to 50 times faster, and in general, 17x is kind of what you're guessing for something reasonable.
And not guessing, as in just the benchmarks on Pydantic Core that are run on every commit. A lot of them have alternate equivalents in Pydantic 1.9, and so that's the speed up that we're seeing. There are a few more optimizations I can make. There are a few. It'll get a tiny bit slower, I guess, when it's wrapped in Pydantic in Python, but a tiny amount. So yeah, I think those are realistic numbers.
Yeah, that's a huge difference. Now, you say when validating a model, how does that performance compare to creating a Pydantic class instance? How much faster does using it in Python get versus
17 times faster doing the validation? You should get your model back. So that is going from a Python object, a Python dict, let's say, of your input data, to a instantiated class instance of your model.
Right. Fantastic. Okay. That is really, really awesome. Next up is strict mode. One of the things I really like about Pydantic is how it will take data that could be the right thing, but is not actually the right thing. Like you said, the string 1, 2, 3, but you really want an integer, the actual number 1, 2, 3. And it just says, this is what we would do if I had to do it myself. I would parse the string and convert it over and so on. And that just happens. But some people don't want this clever behavior, right?
Yeah, exactly. And I think that there are legitimate cases for that. I think there are some people who are wanting it whose cases I don't think are entirely legitimate. But like, yeah, I totally get why in some contexts it's valuable. And so yeah, so it's built in. Yeah, you have that switch from the word go. One of the really cool things that this solves, kind of not by mistake, but as a side effect, is validating unions. We basically run through every member of the union in strict mode first, and try and validate in strict mode, and then validate in lax mode. And therefore, for example, if you had a union of int and string, and then you passed it the string 123, it wouldn't get converted to int as it would do historically in Pydantic. Pydantic now has smart union, but like it's not perfect. But this solves some edge cases like that, and some much more confusing ones than that.
Nice. Related to that is, I would say, is this conversion table that you're putting out, right? What's the story here?
So there's two things. There's this, like, I kind of called it COD philosophy the other day, like this like rule for when you would convert something and when you wouldn't. And actually, it's come out to be really useful in us thinking about when we should and shouldn't convert things. Because, to take an example, we have been in Pydantic v1. You can coerce a set to a list, and that mostly seems to make sense, and it's something that you might want to do in lots of contexts. But actually, if you go up a bit, the single and intuitive means we can't convert a set to a list, because you don't always get the same output when you convert a set to a list, because the order of things can change. And so using this rule has been helpful in trying to be more consistent about what we convert. But I'm the first to put my hand up and say this rule is not perfect. There are always going to have to be exceptions to it. And at the bottom of this of this blog post, but then properly on the docs completed, will be a full-on table of everything and what gets converted and what doesn't in lax mode. So you can look it up rather than having to guess.
Before we move off strict mode, Klutz just has some kind things to say about Pydantic. Says it's one of the most useful packages ever. Congrats.
That's really
but
kind. Sorry,
Magnus Magnus asks, is strict mode a global or a per model setting, or is it a usage when you actually do the parsing? Where do you set this?
It's actually more powerful than that. It is either on a field or on an entire model, and you can set it at validation time. So you can configure it in config and configure it on a particular field, and then you can override it when you're effectively calling the validator.
I see. Maybe there's some situation where you're loading, old bad data or something. You want to say, no, go ahead and do this, but in the future, we're not accepting it. Something like that.
Right. And actually, one of the reasons I built that was to use it in the union, because we go through the validators the first time at validation time, insisting on strict mode. But yeah, I don't. One of the other cases which will come up somewhere down here is we now have a is instance, or a like pseudo is instance method, which confirms whether data matches our model, and there we automatically use strict mode, because for me it's kind of obvious that if you're doing is instance, you want that to be strict.
Yeah. All right, moving on to the next part of the plan is built-in JSON support.
Yeah, so this is
what are we talking about here? Yeah.
So we're talking about parsing JSON in Rust and passing that JSON object straight internally within the library to the validator to then do the validation. One of the big advantages that has is it solves the strict mode problem. So if you looked above, let's say we have the string of a date. Let's say an ISO 8601 date of year, month, day. In JSON, it's obvious that should be validated as a date. But if you pass that in from a Python object, it's not valid in strict mode, right? That doesn't look anything like a date. The problem if we had strict mode without the built-in JSON validation is you can't pass JSON with a date in it, because
there's no scenario where directly going from JSON works, because JSON, for odd reasons, has no concept.
It doesn't have date, but it also doesn't have set or bytes or loads of stuff that you want to use in Python, right? So one of the things that built-in JSON support gives us, as well as obviously a performance premium, is that we can be sensible and say that ISO 8601 date is a valid date in strict mode if it's coming from JSON, but not from Python.
Okay. Yeah. And also just makes it faster, right? Because probably parsing JSON and Rust it's pretty quick.
It's really it's fast. But also we don't have to create a Python dict and a Python list and all those Python types. Creating Python strings has like some significant overhead compared to creating a string in Rust. And in future, once I've got V2 out, I intend to build a custom JSON parser which is even faster and will give us line numbers in errors, which would be really nice because we don't have that now, and we can't do that in V2 because JSON, which I'm using, doesn't provide line numbers. But I hope in V2.1 or something we will be able to add that.
Yeah. Amazing. Really quick on the strict stuff as well. Manoj asks, what about strict int as a type? Is it going to be still around?
That can stay around because that'll be effectively. So it's probably worth at this stage for people if you could just go to Pydantic Core's repo, and we'll have a really brief look at what it looks like. Yeah, and then just in the README you'll see a example. So you see here, right? We up a bit. You don't need to go into all the details of it, but the way that we define a model in Pydantic Core is with this kind of like micro schema, which is defining, in this case, a type dict with a bunch of fields in it. And here on a particular field, we could say strict true. So let's say on the int field, we could say strict true. And that field will be strict while the rest isn't. So obviously what strict int, the Pydantic type will do when it becomes a schema, it will set strict to true on that particular field.
Got it. So it effectively is a synonym for the more general way to say use strict mode, but only on this field, right?
Yeah, exactly. It's just
The
a
way to
marker
do it.
effectively set strict on this field.
Yeah, exactly. So in Pydantic, you can say I have say an age, which is an int, and you can set it to a default value like 0, or you could say it's optional, set it to none, but you can also set it to a field, right, where you have additional information. Is that how you set strict mode? Do you set it to a field and say strict mode equals true or something like that, more generally?
It's not built yet, so it's up for debate. But yeah, effectively strict will be a setting on field and obviously on config as well. And there will be these types which basically contain some extra information, like strict int. We'll just like set that strict to true for that field.
Right, exactly. And for people who are not aware, config is an inner class of the Pydantic model that has a bunch of settings you can set, right?
Yeah. And people do some unholy stuff of like modifying the base version of config and therefore doing global stuff, which I've never done. People seem to make it work. I don't know if it'll work in V2. I don't promise it will.
Yeah, absolutely. One of the things that's interesting with this Pydantic core is now this is a dependency of Pydantic, right?
Yep.
And people could use it directly if they wanted, right? Like validating without a model. You don't have to define a class or any of those things.
100%. You don't have to define the class. If we look in the example we were using there, we didn't have a class. We were just validating to a type dict. So we would get back a dict, which obviously means we have full support for typing's type dict type. It's also a little bit faster than creating a model because we don't have to create the class instance. We just create the dict that goes inside it. Yeah, people could use it without. The only concern obviously is whether or not like obviously it's now compiled and you have to be able to run that Rust code to be able to use Pydantic. With the V0.1 release of Pydantic Core yesterday, we have, I think off the top of my head, 56 different binaries that we released for different environments. The team of the guys at Pyo3 and at Maturin, which is their way of building, have been super helpful. And yeah, we'll continue to support. So it doesn't worry me. We already have the full Pydantic Core set of unit tests running in the browser via WebAssembly. So obviously Python moving into the browser with WebAssembly is like the big new thing. I'm really excited about it. I wanted Pydantic Core to work. And so Hood, who's one of the Pyodide maintainers, I met at PyCon. He's been super helpful actually with Pydantic Core in general, but particularly with getting it to work. And at the risk of running a live demo, if you just go back to Pydantic Core, I know we're slightly changing subject, but I have to show you this because it makes me really excited. If we go up and you go into WASM preview, which is one of the directories that
Yeah,
will be
WASM
shown.
preview. Okay.
And then
Hit the index.
No, if you click here, which just basically
Yeah.
renders that index file. I hope it works.
It'll work. Gotta work.
It's got to work. This is it downloading the binary, downloading all the unit tests, extracting them in Python, and running the full test suite in the browser.
Let me try it one more time. Do it a second time. Yeah. So what we're seeing, if you click on this link, which I'll put in the show notes, is it downloads the CPython runtime in WebAssembly based on Pyodide, I'm guessing.
Yep.
And then
it downloads the archive zip, sends that to Python. Obviously, we're running full CPython in the browser, so we can use the zip package to extract the zip, extract that into the virtual file system that Inscripting gives us. Then we install the WASM32 wheel. We basically do pip install, micro pip, which is the way of installing stuff. And then we just call PyTest, and off it goes, and it runs the tests.
And you just see the test come by, standard colorized PyTest output, 1,465 tests pass in 5 seconds. Pretty fantastic.
Yeah. So it is a bit slower than full CPython, but I'm still like really stoked for what this is going to mean to the future of Python, and particularly to stuff like the context where you might use Pydantic of data processing and stuff. I don't think Python is going to replace React, and I think it's a bit daft of people to suggest it will, because that's just going to lead to disappointment. But in context like this, it's going to be super valuable. And one of the things I'm really looking forward to is Pydantic 2's documentation. Every single example is going to be executable, so you can edit it and you can press run right inside the browser, which I think should help a lot.
Yeah, fantastic. Have you been tracking PiScript?
Yeah, I have been tracking PiScript. It's obviously it's very cool. It's wrapping Pyodide, which is where all the genius work is going on. I'm using Pyodide directly, and I think I can continue to do that. But yeah, it's providing a bit of a super helpful wrapper for those who find need a bit more help, and it's simple as a script tag.
Yeah. Okay. Let's see. Yeah. Question from David out in the audience asks, with at least 2 of your projects switching to Rust, Pydantic, and watch files, do you see it as a general trend in the Python ecosystem? In things like PiScript, which I just pulled up.
I have a third one, actually, rtoml, which is a wrapper around the Rust toml library, which is a bit less necessary now when there is better toml support in Python. But a couple of years ago, when the main toml package was not working for me, I wrapped that. Yes, I do. I was saying earlier that I think lots of the low-level tools should be written in Rust. There is a massive space for someone to go out and build a raging fast ASGI framework in Rust, and obviously use a Rust web framework and just provide ASGI interface. I'm looking forward to someone doing that to replace the likes of UVicorn. Not that UVicorn's great. It uses watch files, in fact, so not to criticize them, but there are a bunch of low-level stuff where performance matters, which totally and I think should and will end up being more in Rust.
So you're suggesting something like what you have for Flask, but everything is Rust except for just your view methods happen to be Python, and click that together with Pyo3 or something like that.
That's the ultimate place to go to. I think that the place to start would be, so we have WSGI, which many of you will heard of, which Flask and Django run on. We have ASGI, which is the async equivalent, which is basically, it's great because it means that to build a web framework, you don't have to deal with HTTP. You deal with a dict, which is basically got fields and body and stuff like that, right? And some function to get the rest of the body in the async case. And that's what we have now. And we have Starlit and UVicorn, which are both built by Encode and are both great, but they have a separation by using this consistent protocol in between. And that allows really cool innovation on both sides. My suggestion is we don't have to get rid of the Starlit or the Fast API or that level, but we could do lots of the low-level HTTP parsing in Rust. Before I get shouted down, I'm sure that uvehicle and other such libraries are in turn using some optimized C for passing some of the HTTP requests. So I don't have a number for the speed up, but
Right. Okay, but yeah, it's a very interesting idea. One thing I did want to sort of touch on here is you talk about how there's not going to be a pure Python implementation of the Pydantic core because
yeah,
it's already this complex, specialized thing in Rust, and why do it again in Python just so there might be some edge case where it'll run. Talk about maybe the platforms really quick that's supported for the WebAssembly one we just spoke about, which is fantastic, and I think that's going to open up a lot of possibilities the more stuff we have in WebAssembly. But
I
there
think
shouldn't be a big problem with this, right? That it's
shouldn't. I think with what we have there, we've covered the 99%. We're probably into the 99.9% of platforms covered where people actually want to use this. The only place where I know that there's a slight challenge is on Raspberry Pi, where the normal install of Raspbian or whatever it's called uses their own wheelhouse effectively for installing wheels, which doesn't yet support build of Rust. I'm sure it will one day, and you can just tell it to use PyPI and it will work. But again, this is the kind of thing where, having built watch files and distributed that, I've worked through a lot of these problems, and I'm pretty confident we're not going to find some really important really important environment where it's just not going to work. And
right.
again, as more packages adopt Rust, we'll smooth out those problems, we'll learn from them, and we'll be able to fix the edge cases.
Yeah. One benefit of that is previously Pydantic itself had some Python and other things where it needed to be faster. But because
Yeah,
now it can just use the Pydantic core, what's left over is pure Python, right?
right. And one of the big problem, well, there were two problems with that. It made the development process a bit slow because we basically took vanilla Python, we compiled it with Python, and we got a kind of 50% speed up. And we have to do some slightly weird things. So occasionally you have to return union of just string to prevent Python from casting that string to a native string and losing substrings, stuff like that. Some weird edge cases that bite people occasionally. But the biggest problem is that means that the Pydantic binaries are massive, because these Python compiled versions of Python code get really big. And obviously, moving the performance critical bit into Pydantic Core gets rid of that concern, and Pydantic itself becomes a pure Python package, easier to hack on, CI will run faster, the whole process should be sped up, and it'll be much smaller.
Yeah, it'll be more approachable, right?
Yeah.
People they want to contribute to it and so on. One thing that I did want to ask about, let's see, losing track of my thought here
Sorry, it's
on
been
this
jumping
one, but
around.
no, I know. I had something I want to ask you about the binary version here. Oh well, we'll move on because I can't remember what I was going to ask you. But let's go. I jumped around because I did want to talk about this compiled stuff. Right, you'll just get that as a wheel. Almost everybody, they won't really know or care, right? They just pip install it. It doesn't matter that it's Rust. It just downloads as a binary, right?
Right, exactly. Same as loads of packages you use now,
Right.
Pydantic included,
NumPy
are
and whatever.
compiled.
Yeah.
Right, they're all
Yeah.
compiled. Right, and if there is no wheel available, then pip will do its very best to try and compile that for you. So in the case of Pydantic Core, it will, if you were in some crazy environment where we didn't have a binary, you need Rust installed, and then pip will take care of compiling it for you. But
Yeah.
like I say, that's going to be super rare. And realistically, if you have that problem, come and create an issue, and we'll add the binary for you.
Sure. Okay. Picking up back on the plan here, you have required versus nullable changes.
We missed out one of the really cool things above. I don't know
Okay.
if we're moving order, which is the removing of the necessity for a model. Um,
Right.
so as we saw earlier in the Pydantic Core example, we can validate. So in Pydantic 1, everything was in the end a Pydantic model. So we looked earlier at fast API passing parameters. In the background, fast API is creating a model, doing the validation against that, then extracting stuff from the model and passing it to the function or whatever else. Similarly, if you wanted to parse a type dict, you basically, somewhere in the background, there's a model. We validate against that model. Then we take the dict from that model and pass it back to the user. That had some really confusing and annoying edge cases, but obviously the main thing was it did have a performance impact. Now there is no fundamental kind of base type in Pydantic Core. You can validate an int or a string or a union of different stuff or a model or a data class or a type dict, and you just create your schema and off you go.
Fantastic. So basically, there's this low-level fast engine that'll just validate all sorts of things if you want to use it directly, right?
Yeah. And one thing important to add just while we're on that is there is stuff that's not going to be in Pydantic Core. I don't think we'll add the URL type, for example. There'll be some, custom types that we don't add. And obviously, if you want to implement your own types, then the way that we get around that is that Pydantic Core has basically a function validator, which is basically call a function, either having done some validation before or after, and return the result. So that's how we're gonna provide a way to build validators without writing Rust.
Right. Fantastic. All right. Required versus nullable.
Yeah, probably a like hangover from again me building Pydantic on my own for what I needed, and also from it kind of predated data classes, at least in some of the work, and so there was the real problem for me was the word optional, and the idea that you had a field that was required but was literally called optional. Obviously, Pydantic's not the only library that has that problem. And the real solution is the pipe operator, which is the new way of doing unions. None involves not using the word optional. You can obviously also get around it by using union of string int. But the point is that if you just have a field that is optional int, it is required but can be none. And that's really just to match data classes and other contexts.
Yeah, the new way to express optional for like string pipe none versus optional string. Yeah, that kind of set you free to think about this differently.
Yeah. Also, I literally asked Guido about it at PyCon, and he was like, he didn't say yes, we made a mistake. He said that's fixed by having pipe none, which is a roundabout way of saying we kind of made a mistake back then. But typing has come a massively long way since someone settled on the word optional. So I get it, but it has been a source of confusion that's now being like cleared up.
Yeah, for sure. And there's other things that have been changed as well, right? You used to have to say from typing import capital L list, you'd return a lowercase list, but it'd be a capital L list. And now it's like, you know what? Lowercase list works too, right? You don't have to.
Now we just have the weird side case of any, where there isn't any function, but you can't use it. But we won't go down that line.
Yeah, for sure. Want to talk about validated functions?
Yeah, I touched on them just now, and like I said, we have the idea of before. So we do a validation before, and then we pass the result of that validation to a function. We have validate afterwards, and plain, which doesn't do any validation, just calls the function. The most exciting thing, and probably one of the things I'm most stoked for in Pydantic v2, is these wrap validators. So you'll have read about middleware in Django or any web framework. We have this idea of an onion where we call a function which takes a handler to call the next function. We have the same thing here in Pydantic v2, where we have these, I've called them wrap validators. They take a handler to a function and then they call that. The power here is obviously we can do some logic before the validator, we can do some logic after, we can catch errors, we can return a default value. It gives us like loads of flexibility to do more powerful stuff.
Yeah, that's very neat. Yeah, you basically can do whatever you want and decide to delegate down to the chain of handlers if you want, or skip it, right? You say, this looks good to me. We're just going to return a value here.
In particular, with Pydantic 1, there was no way to skip validation if you had a validator. So, which obviously caused a slowdown. If, let's say, you had date time now, you still had to call the validator, which sure enough got a date time and was happy, but you had to go through that logic. Whereas here, we know it's a date time because we've written that code. There is the potential for people to make mistakes and not call the handler. If they wanted to return the raw value, then that we can't stop them. But that's Python. There aren't always guardrails.
Right. Yeah. It's some of the power is in the flexibility, all right,
Yeah.
but that lets you do bad things as well.
Yeah. I
You
mean, we
also have
could.
this. Yeah, go ahead.
Sorry to interrupt. We could theoretically do some crazy thing where we checked if the handler was called and raised an error or a warning, but I think at this point we let people make their own mistakes if they
Yeah.
insist.
Well, and you also would pay a performance price for all the places where it's used correctly.
Yeah.
Trying to do that kind of stuff, right? All right. More powerful aliases.
Yeah, this is
Maybe
a feature that I
tell people what
saw.
aliases are, and then then
Yeah,
what's the use here?
aliases are the idea that we have a name for what we want to call a variable in our code, but we know that in the real world where the data is coming from, say on the front end, it's got a different name. Often it's camel case on the front end
Yeah.
because it's JavaScript, and we want to use uh, snake case in Python. But also, we're using some API, and it has to be called something when the data is coming in. And so we had that in Pydantic v1, the idea that you could have a field that was called something else externally. But this is actually a feature I saw in the Rust CERD library, which is the main validation library. This idea of flatten, so basically take a value not just from the top level dicts, but from deep down in some object we pass it, and use that for the field. And so again,
Right.
this is
I
one
see
of the
this kind
things.
of stuff. Yeah, sorry. I see this stuff all the time where you will get some huge response from an API, but you're like, I just really want this little part here. And so what you end up having to do is say, okay, capture that result as a dictionary, then navigate down to the 3 levels and get the sub object, and then pass that to Pydantic. And here you could just say the alias is, sort of traverse that down and start from there, right?
Exactly, and we get nice advantages like if that thing's not there, we don't get an error because the get none has no get method or whatever it might be. Pydantic will take care of just saying that feels missing if, let's say, Baz was a string, so therefore we couldn't get Baz second element, uh, you know quux, whatever that is.
Yeah. So in the case you have here, you say the alias is a list, and the list is Baz and then 2 and quux. These are things that are appearing in this JSON document of
Yeah.
the dictionary.
So that
And what it
list
will, yeah, go ahead.
is effectively some location, but what you'll notice again is there's actually another outer list because we can have more than one of these. We can have it as deep as we like. As many different aliases to try as you want.
Right. Yeah. So this actually traverses down, and the 2 means go to the third item because it's 0 based in the list, and then look for that element. That's pretty powerful.
Yeah. And again, this is the kind of thing that we can do because Pydantic Core's in Rust, and the overhead of having aliases of multiple different types is basically absolutely minimal because in Rust it's a single enum lookup, and if we have
Yeah.
a simple alias of a string, we don't need to worry about any of that crazy logic to recurse down. We just take the top an element out of the top level dictionary and move on.
Right on. Jonas asks, would this solve when my app gets Pascal case? I want to work with snake case and then return a camel case. Is there some way to express that kind of stuff with aliases?
This does not, but there was a pull request for Pydantic 2, for Pydantic 1, where we had load alias and dump alias, so a different alias when we were exporting, and I do intend to support that. So this particular feature is kind of related, but won't solve it on its own. But yeah, I do intend to allow 2 different aliases.
Okay. Speaking of loading and getting back out, improvements to dumping, serialization, export.
Yeah, there's a bunch of stuff here that people have wanted for a long time. In particular, being able to create a JSON compliant dictionary, but also people wanting to do their own customization. Again, my hope is that because that dumping logic will be implemented in Rust, we can get I'm going to call it kind of zero cost extra features, because in the end it's should be just an enum lookup to do the complex stuff, and if we're not doing the complex stuff, we go the optimized path. There's what we've realized is there are a whole bunch of different things that people might want. They might want the raw data, including submodels. They might want what Dix does now, which is recursively convert models into dictionaries, but otherwise keep stuff unchanged. They might want a JSON compliant dict, as I was saying, or they might want full serialization to JSON. And obviously, that last one in particular, we want to be quite well optimized. Well, we want them all to be, but effectively,
the last one's the most important.
Yeah, we want we want to be able to provide someone complete flexibility without it harming performance in the case where they're not using that. And that's what I think Pydantic Core has allowed already on validation, and I hope will allow on serialization.
Nice. All right, we're getting a little short on time, so let's maybe
Yeah.
let's why don't you pick out some of the remaining stuff that you want to focus on? I think maybe the most important is a model namespace cleanup. What do you think?
I mean, I think context that I was just going to mention here, that's going to be
Yeah.
another amazingly powerful escape hatch for some of the things people want to do. Obviously, the main use of it is for allowing validation against some dynamic data, but you can also update that thing. It's just a Python object. So if you wanted some case, we were talking about wrap validators earlier, where you've got errors and you want to raise a warning, you could append to context the warnings. So that is another super powerful escape hatch without harming performance for everyone else. How
Yeah,
it's going to work with Fast API, where you do the validation before calling user code, I don't know yet, but I'm sure
how do you
Sebastian will
provide
find
that
a way.
data that is the context, right?
You have another dependency, I guess, in Fast API lingo that generates your context for that particular call.
Yeah, I was thinking some of the dependency injection stuff, which is not very popular in Python in general, but that might be the way you might register. Here's how to get the context for these types of models or something.
Yeah.
Yeah. I mean, Sebastian will decide, but that's what
I'm
came to
sure he'll
mind when I
find a way
thought
to
about
do
it.
it.
Yeah, for sure. One quick question just on usage here. Like I see that you're saying user and then model validate JSON with this data. And you could also just say user star data. I know you're doing this different here so you can pass the context, but what would you say is the best way to create these objects from that kind of data?
Model validate JSON is going to be there, and it's going to be named that or something close to that. And the point is that's taking a string of JSON, or in this case, bytes of JSON, and validating it directly. We talked about that earlier on.
Yeah.
So that's not the same as user star
Right.
post data because it's bytes. There's also model validate Python, which is effectively the same as model star data, except that because obviously we basically don't trust anything you pass to it. That's all external data. You can't pass context that way.
Okay. Yeah, exactly. All right.
Which I think comes onto your question about the cleanup of the namespace.
It does. Yeah. So there are some breaking changes, and there's a decent number about sort of renaming some of these model methods and stuff, right?
Yeah, I'm not too worried about these because we're going to leave the old functions there with a depreciation warning on all of them. So that will be quite easy. The stuff that's going to be really hard in terms of breaking changes is like where, for example, I talked earlier about sets no longer being coercible to a list. There's no way to give a warning about that really without absolutely peppering Pydantic Core with like warning logic that would be horrific. So there are going to be the things that are going to be most difficult for people are going to be like silent breaking changes. I'm not particularly worried about functions that give you a warning when you call them and say use the new name. It's going to be the silent stuff or the fundamental changes in behavior that are going to be hard. But again, there's no way to make Pydantic better without doing that.
Right. Fair. Okay. Let's see. I think it's worth pointing out the error descriptions now have a documentation link. That's kind of interesting.
Yeah, I think that's going to be super powerful for people. I don't know anyone who's ever used Cargo and Clippy, which are the Rust tools for broadly speaking linting and compiling. Whenever you get an error, there's a link basically to give you more information. And obviously, a lot of these links will be being shown to developers through APIs, and we can't provide all the information we might like in a one sentence message. And so we're going to have a bit of Pydantic's docs dedicated to information on every single warning, every single error message, and what can happen. It leads to another interesting question about Pydantic 2 and what we do with the documentation and the licensing of it. So Pydantic is definitely going to stay MIT licensed, might be dual licensed Apache 2 if someone can tell me why that's necessary, but it's going to stay permissively licensed. But I'm kind of becoming aware that the documentation, which is valuable and will get better and more valuable, is currently MIT licensed, and some company could take it all and bang it on their domain totally legally. So I might change the documentation license to something a bit more restrictive to say, for example, you can't take all of these error message documentation and just put them on your own domain, or at least we have some way of making that possible without allowing people to commercialize that. Mostly because it would get really confusing if there was Pydantic's documentation that's up to date and Foobar Company who publish the whole same thing but leave it out of date, and they both come up on Google.
Yeah. It's interesting to think about having this mixed model in your repo, because obviously you want Pydantic, the library, to be wide open for people. But then there's this supporting stuff that you might want to treat differently.
Yeah, and I know that the Linux distributions are going to be super spiky if any of that stuff that's not MIT licensed got distributed, right? Because their package managers have to have stuff that's correctly licensed. I mean, obviously they allow stuff that's like GPL or something, but I'm thinking about something. Problem is GPL doesn't stop you publishing documentation, so. Yeah, it's an open question. I don't want to have a separate repo for documentation because it'll make creating a PR that much, higher friction. But I think I need to talk to an IP lawyer before I say anything authoritative on this. Is what I guess I'm getting to.
Yeah, I'm feeling entirely unqualified to give any advice on this, but it's tricky, right? As we were talking before we hit record, like if you have a license in a subfolder, does that license override the more broad one? Do you have to go and change your broad license, your MIT license, say, here's the MIT license, except for this section of the repo, this doesn't apply to, see, it's licensed. It's weird.
I presume that the big projects, the Django's of this world and the NumPy must have thought about this stuff, so probably worth doing some research on them. But I'm thinking out loud, and I probably need to come up with a conclusive answer before before I say more.
Well, it's called a plan, not a release, right? Yeah. Okay. We talked about the Pydantic becoming its own license. The one that I want to talk about is from ORM and friends. I guess maybe talk about these sections here, some of these changes.
So there's a whole bunch of improvements here that we could talk about for an hour, probably on each one, let alone full. But the from ORM was a bit of a strange case where you had to have a config flag and then there was a method on a model. Pydantic Core has this built-in from attributes power, which basically allows it to recurse through some Python object that is not a dictionary instead of a dictionary if you switch that on. So we talked earlier about aliases and about hunting down through some complex object, normally of dictionaries, if that came in from JSON, but like in lots of contexts, and ORM in particular, it's not, right? So from attributes, it lets you basically do that same finding things in an object from something that's not a dictionary via basically get attribute, not get item, effectively.
Yeah, and that makes a lot of sense because then you could just pass any class that you got from anywhere. You don't have to find a way to get it to a dictionary. That's great.
Exactly. And Pydantic should take care of that and give you nice warnings when at like the third level it gets the right error, or it gets a type error. It'll tell you type error, and if it's an attribute error, it'll say not found. So
got it. Yeah. So from ORM, to me, that felt like, well, here's a way to integrate it with SQL Alchemy or something like that. But this is just more general to say we're moving to something that just says, given any object, just go get it.
I mean, from ORM was a dumb name. You're quite right. It came exactly from compatibility with ORMs and SQL Alchemy, but in particular. But yeah, in what we're actually doing is taking stuff from attributes. So the new name makes more sense, and the new functionality is like a lot more powerful.
Would from attributes work on properties in addition to fields?
It should do, yeah. Yes, it does. There's a unit test for it. It does.
Okay. Oh, fantastic. That's really cool because your class might have computed elements, but you want them to show up in your JSON, right? Or something like that.
Yep.
So
yeah,
cool. All right. I think that might be it. One more question I have for you. When I was doing C, C++, C#, I remember thinking about numerical types a lot. Is it sufficient to have an int here? Do I need a long? Is it an unsigned long? How much data could it be? What happens if I have an int and I increment it and now it's negative 2.1 billion or whatever? Like there's all these weird scenarios that go away in Python because Python uses a slower but way more flexible numerical type, right?
Yep.
All the
So
stuff happening in Rust, I feel like you might need to think about that a little bit.
yeah, so it's all I32 in the case of ints. So we're limited to whatever. So I64, sorry, I64. So whatever the limit is on I64, that does mean that you can't pass in. Yeah, you had it there.
Yeah, yeah.
Whatever 2 to the 64 is. There we are. There's the number.
I
If you
don't
try and
know
pass
how to say that number, but it's like a million
big,
trillion times 9 or something.
yeah, you would have trouble with. You could use a functional validator. You could find a way around it if you had to, but yeah, I think that's a price worth paying for the fact that we can do integer stuff really quickly, right? And we can do bounds
Sure.
checks much more quickly. Yeah, and we have nice errors in there if you do pass in something bigger than that, or if you pass float inf. Again, we'll get infinity, same as we would if you got a number above that, or float nan. Again, you'll get int. That's not allowed. So those cases are all taken care of, and they give you a nice error. And there would be an escape hatch if you really had to.
Right. So the escape hatch could be, you might write a validator that checks, is the number in Python, it checks, is the number bigger than this limit? If it is, raise an exception, say number too big or something like that.
Yeah, I mean, there isn't actually an escape hatch in the case of JSON because we have to do the parsing before we get there. So you'd have to pass your JSON externally and then pass it in as a Python object and do something weird. But
It's
again,
uncommon as you get insanely large numbers like this.
I think that though insanely large numbers like that come up when people try and break things, almost
Yeah, they try
exclusively,
to
right?
break
Like,
things, or they're trying to do some odd math problem where, like, I'm trying to use recursion to compute and see how many prime, something like that. But in the general day-to-day of I'm accepting like user input over
right.
an
I mean,
API,
what I
not
would say
really.
is that as a Unix timestamp in milliseconds is beyond 999 in years, right? It's
Yeah,
beyond a date that anyone's ever going to want to use.
yeah,
So I don't see that being a problem really.
yeah. I don't either. Actually, I think there's probably, I don't know how to make it happen, but there's probably some interesting performance story for Python getting faster if it could work with real numerical types rather than these super flexible numerical types. A lot of times you'll see examples of math and it's like, well, okay, this
Yeah.
pi long object thing, instead of working just with true ints and floats and stuff, really slows it down. So I don't know. I see a future maybe someday where Python actually adopts these sort of limited types like this potentially. But
Isn't that
for
what kind of libraries like Number are doing? They're allowing you to
yeah,
selectively compile a function without going completely off on a tangent. I think
right,
that's one
exactly.
approach.
And there you explicitly say whether it's an ent or stuff like that, right? Mhm.
I think
Cool,
the other
cool.
option would be another way would be to say you don't want to be writing Python at that point because you want all the tools available in Rust's syntax to allow you to say all the stuff you want to be able to say and do integer overflow nicely. So the other option would be at some point there'll be a way to basically write Rust even more easily than now inside Python. Those of us who are using PyCharm and are really lucky that we get PyCharm and we can get basically syntax highlighting in any random string, that doesn't seem too crazy.
Yeah,
And obviously
I
even more
agree.
so if you were importing a file. So I think there are lots of ways around it. Yeah.
Yeah, we'll see. Maybe more stuff to come together with the WebAssembly feature. Who knows? Anyway, lot of stuff to think about. I think this. I didn't bring this up because I feel like this is a problem or anything. I brought it up just because I wanted people to be maybe aware that there are some slightly different data types at play here, since it's going through Rust.
Yeah, I think it's important to see that under the hood we are doing. Yeah, exactly. And
Yeah,
so we didn't talk about time delta validation, but I've built a library in Rust for doing that a bit faster than all the ones I could find. That is, for me, makes the right compromise called speed date.
okay.
And that is having to deal with exactly those overflow problems. And I fuzzed this library a great deal and found a whole bunch of overflow issues by fuzzing it because when you're doing raw parsing in Rust, you have to think about that stuff that those of us who come from a Python background haven't even thought about.
Yeah.
The idea that adding two numbers is scary and might result in a panic is
Yeah,
new.
I honestly, I hadn't thought about it for a while. It's kind of nice to just not have to worry about those things. You used to just always have to consider, Is it okay to add? Is it okay to multiply these things? Because
Yeah.
even if that's just an intermediate value, something insane might happen along the way, right?
Yep.
Yeah, cool. All right. Well, thank you so much for working on Pydantic, putting it out there. I know it's made my code and my projects much nicer. 72,000 other people agree, it seems like.
No problem. Thank you very much, and thank you so much to all of the people who help with Pydantic in every way, from like Eric and Sebastian and people who work on it quite a lot, but also to like all the people who create issues and submit one pull request. It like makes my job a lot more fun, that it's not just me sitting in an ivory tower doing it on my own.
Yeah, absolutely. It's much more fun to work on projects with people.
Absolutely.
Magnus says, thanks for the great show and all the work on Pydantic. Looking forward to Pydantic too. Right on. Now, before we get out of here, final two questions. If you're going to write some Python code, work on Pydantic, what editor do you pull up?
I pull up PyCharm. I'm a complete convert. I completely rely on it. Yeah.
Right on. And notable PyPI or even cargo package, I suppose. Whatever you want to shout out to some external library out there that you think is pretty cool. People should know about.
It's not going to be particularly interesting because we talked about it already. But Pyo3, I'm like forever impressed by what those guys have done, and obviously they've made what I'm working on here possible, and they've been really helpful for me when I've asked dumb Rust questions. So yeah, thank you to them. And yeah, if you're ever thinking about getting into Rust, doing it from Python is a really, really neat way where when you can't work out what the hell's going on, you can kind of fall back to Python sometimes.
Right on. There's a audience question a while back about any resources that you might recommend for learning Rust, sort of on the journey to getting to Pyo3 and so on.
No, I'm like, people always ask me how did I learn to code and where did I do it, and I basically smash my head against the wall until it compiled.
Yeah, I hear that. That's a pretty common way. Okay, final call to action. People are interested, excited, they have feedback, something like that. They want to try out Pydantic 2.
Particularly if you're using an unusual environment, install Pydantic Core right now. Pip install Pydantic Core, and just run the simple example as one, for example, on the release. Check it compiles, and if you find an environment where it doesn't work, so it not compiles but runs, let me know, because that'll be easier to fix sooner rather than later. And then most of all, once we get to the betas and alphas of Pydantic v2, please come and try it then, because again, it'll be a lot easier to fix it before it's released than after.
Yeah, absolutely.
And I'll do a lot of shouting on Twitter about that when the time comes.
Perfect. All right, Samuel, thank you so much for being here. Thank you for your work on Pydantic and everything else. Yeah, you bet. As always. See you later.
Cheers.